So we're going to look at complex rational expressions. That's our next kind of stage in this idea of rational expressions. And you have complex rational expressions that are also called complex fractions. And the reason they're called this is because we take a look at this fraction. We've also got a fraction in the numerator and the denominator. So things are getting a little messy. So I'm going to show you how we can simplify this, because you're going to be asked to simplify these types of problems. So if we just take the numerator to begin with, 1 over 1 plus x. One thing we can do is we can take this and turn it into a single rational expression rather than 1 plus 1 over x. So when we do that, what we're trying to do is get it all as one fraction. So what the beginning is missing is we have 1, and we should multiply that by x over x. That way, we'll have a common denominator in the numerator. Interesting. And when we do that, we have x over x plus 1 over x. Now we have a common denominator, and we have in the numerator x plus 1 over x. So that's our numerator. That whole thing is our numerator. I'm going to put an n. And then let's do the denominator. This is the second step you see on the side. I'm just noting what we're going to do as a method. This is our denominator. Same idea. 1 times x over x minus 1 over x. Stop it. You don't want to be in the video. Equals x over x, and then minus 1 over x. Probably don't need to write all that, but I want you to make sure you see where it's all coming from. And we're just going to say that's the denominator. So now we have this, x plus 1 over x as our numerator, and our denominator is x minus 1 over x as our denominator. So what I like to do is I like to take these, because I always disliked the looks of so many fractions in one problem, right? Just getting taller and taller. So what I like to do is I like to write it horizontally. X plus 1 over x divided by x minus 1 over x. And my favorite team, the New York Yankees, always help me remember to do this. No, I do not flip this, so I leave this as x plus 1 over x. Yes, I changed division to multiplication, which also means yes, I changed this to x over x minus 1. I do the inverse reciprocal, because we know that dividing by a number is the same as multiplying by its reciprocal, that property. And that's why the New York Yankees are so mathematical and so helpful. When we do this, we get a nice, compact problem. But let's take a look at it first. Is there anything that we can, since it's multiplication, maybe there's something that we can reduce? Look here, we have x divided by x. So that's 1. And all we have left is really times 1 here, times 1 here, because we just canceled those. We have x plus 1 over x minus 1. So that big, ugly problem reduced and simplified to x plus 1 over x minus 1. And that's what we did just to simplify as an example, this first complex rational. Well, the second method we could employ on these types of problems is we can also find the least common denominator of the numerator and the denominator. So if I look at this, the least common denominator of the numerator is x, and the least common denominator of the denominator is also x. So what we can do is we can multiply by x over x. That's just a form of 1, so you're still going to obtain equivalent fractions. When we do that, well, just think we have distributive of that x. We're distributing the x. And here we're distributing the x to both terms, right? So in the top, we are going to get x plus, really, x over x. And in the bottom, we have x minus x over x as our terms. And that's nice because that just gives us x plus 1, because that's a form of 1 over x minus 1. It'll be up to you which method you use to employ, but we should note that if we look at this here, we're going to have to say what x cannot equal, because not only are we simplifying, we're trying to find out what makes x equal 0. The denominator in the beginning, if we use x equals 0, we cannot have x equals 0 because we get an indeterminate, 1 divided by 0. In the numerator, we get an indeterminate form that's undefined. So we cannot use x equals 0. And the other one we can't have is positive 1. So if we have positive 1, and you can see that in the beginning, 1 minus 1 over 1 is 0. That makes the whole denominator 0. So we have simplified, and then we have what x cannot equal. Everything else is okay. All right, so I'm giving you another example of a complex rational expression. This one is actually something you'll see in beginning calculus. And when we look at this, we have a complex fraction numerator, denominator, and what we're going to do here is we're going to find the least common denominator. And really what we're going to look at is we're going to look at these three. So if I look at those three, there's nothing common about them. So we have x plus h, and we have h. And those three are going to have to combine to give us a common denominator. Okay, so what we'll see here is we're going to take x times x plus h as our common denominator, and we end up getting this to look very similar to this problem. So when we take 1 over x plus h times this, we get x times x plus h over x plus h minus, now distribute, x times x plus h all over x. Now for the denominator, we get hx times x plus h. You should be able to see there's going to be some things we can factor out here. This is 1. This is 1. So on the top we have x minus x plus h all over xh, x plus h. Those cancel out. You're left with h over xh, x plus h. Notice again we do have 1. We have 1 over x times x plus h. And if we go back through here and look at the rest of this, first of all, we know that x cannot equal 0, so there's 1. We also know that x cannot equal 0 from there. H cannot equal 0 from here. And then we also know that x cannot equal a negative h. So x cannot equal a negative h. You have to come back here. Didn't put parentheses there. Should listen to my own advice. Didn't put parentheses there, so that actually makes this a negative h. And that's just going to change that to a negative. So when all's all said and done, we actually have a negative 1 over x plus h. And that's why we can't have the x be equal to 0 from earlier on the top. H cannot equal 0. And then x cannot equal negative h.